Hello! You thought you were going to miss me today, but you don't have to because I'm here. Okay, are you stuck on number one? Let's talk about it. Number one, I've got some tips over here. Did you see those? I hope those are useful. I'm going to use them while I'm doing this video for you, okay? Okay, here we go. And number one, maybe it would be easier if I did this. Can you still read the word tips? I hope so. Okay, we've got a worker who's got to move a crate. Notice that I'm telling you that the crate is 17.0 kilograms. That is a mass, right? Not the weight. So that's M. Okay, if I want to know the weight of the crate, I'm going to have to go weight, force due to gravity, is equal to mass times acceleration due to gravity. All right, so I did not give you a weight. I gave you a mass. All right, I'm also telling you that we're applying a force to this block. That applied force is 49.0 newtons. All right, we also know that there is some friction. We are given a coefficient of friction, but we're not given the force of friction. But we can certainly find the force of friction because we know, hey, that's a shame. There we go. We know the force of friction we have an equation for that. Force of friction, kinetic friction, is normal force times mu k. Okay, and then we also know that we've got my normal force here. If this crate is just sliding along the floor, we know it's not accelerating up or down. So we know that the value of my normal force is equal and opposite to the value of my gravitational force, right? And so if we can take mass times acceleration due to gravity, and I know you have that number memorized, then you can find your normal force. All right, then, once you've found your normal force, we've got this. And then, once you've found that, we can plug in my mu k, which is 0.214, according to the information in the problem here. And then I'll be able to find this piece of information. And I need to do that because I was asked the resultant acceleration. And so if I'm asked for the resultant acceleration, I'm specifically asking you for the acceleration in the x direction. Okay, so we know that the sum of the forces acting on this object in the x direction are the mass of the object times the acceleration in the x direction. Okay, so if I want to know this, I already know my mass. I need to know this. I need to know the sum of the forces acting in my x direction. Well, what two forces do we have here? We have frictional force and my force applied. So if I can find out what my frictional force is and subtract that from this number, and I'm saying subtract because we know that this is acting in that negative direction. Let's think of this like a normal XY plane where this is positive and this is positive and this is negative and this is negative. So my force of friction is acting in the negative direction, so this should be a negative number. I'm either going to add a negative or I'm going to subtract a positive. Whatever you want to do, as long as you know that these are acting in opposite directions. Okay, did that help? I hope so. I'm not going any further. That's all you get. Watch it again if you're unsure.